week 2 of our 6-week webinar class. The topic of this week's discussion is data entry. William Bannon again bringing you the presentation. All right, as we go through our topics, it's always very important to keep in mind where we are in the process of our 7 steps of data analysis. So as I said, this week we are at the 2nd step, which is data entry. Just a few comments about data entry before we get started. Data entry is often seen as I guess, as sort of not the more, but almost the most nominal part of data analysis. So you'll find when when somebody needs a task to do, in the research project, if they have the least amount of experience, they're often ascribed the data entry. In addition, there's also not a lot of instruction available on data entry. So if you are assigned that and you don't have a lot of experience, it's hard to find where to do data entry correctly. Right? However, the entire study hinges on data entry being done right. So if you write a grant and you get funded for a study and you implement the study and you collect the data and everything's going great and you accurately gather every piece of data perfectly, if it's not entered into the software database correctly, it almost might as well not exist, right? Because you can't analyze the actual accurate data that was collected if it's not entered into the database correctly. So the entire validity of the study hinges on correct data entry. Now, data entry is actually more than data entry. And what do I mean by that? Well, we could say that there are 3 main areas of data entry. First, you need to code the data. So number 1, coding the data. 2, there's the process of entering the data. And then 3, there's the process of cleaning the data. Okay, so you can see here, data entry breaks down into 3 areas. And just like our Russian dolls, within each of these areas, there are more sub-areas. Okay, so coding the data. Coding the data includes creating well, first we're going to give names to the variables, right? We'll see that in codes, but also it includes listing those names and codes within a data dictionary that you must create. The process of actually entering the data. Now, of course, you can't enter the data unless you have an SPSS database to enter it in. Right? So the entering the data also includes the process of creating the software database. Next, there's the actual process of entering the survey data, so taking the hard copies of the survey and entering that data into the software database. And then 3, there is the process of cleaning the data. So you can see here there are 4 subpoints, which are more than the other 2 put together. So cleaning the data is also an involved process. So first, you can reference the survey hard copies, relative to what's in the database. Second, there's examining the variables. Third, we're going to look for violations in logic. And then 4th, we're going to recode any variables that need recoding. So we'll take this one area at a time. So first, part one, coding the data, with the subcategory of creating the data dictionary. So, coding the data. The first thing that we should do when we code the data is give each survey item a name for entry in the database, right? So, we're going to give, you'll see, a short name to each survey item, and that will correspond to that item's name within the SPSS database. And two, each response to each item gets numeric codes. And then three, these names and codes are listed in the data dictionary, right? So you create the names and codes. You can't just remember them offhand, so you list them in a data dictionary. As an example, so take this, the beginning of our study survey for our sample study, right? Just the first few questions, just to illustrate how this would be done, right? So let's say that this is the beginning of our study survey. Okay, and this is a question 1, 2, and 3. And so you'll see in the upper left-hand corner, the first variable is ID. Right? So this is the study ID assigned to each study participant. Right? So this is number 1. So the first variable in the upper left-hand corner is ID 1. Okay, that's almost every study. You need to give an ID, and you have to put it on the survey. So when you enter it into the database, you could find the survey, the hard copy of the survey, that corresponds with the case in the database. So the first actual item, number 1, is highest education level. Right? So we see 1 highest education level. And in the possible responses, these are very truncated, just for to illustrate our point. But high school GED A, B is college 4-year degree, and C is graduate school. Again, there's many more categories. This is just shortened to prove to illustrate our point. So 2, personal income from last year, measured in thousands. And 3, have you ever had a drink? So have you ever had a drink of alcohol? To shorten it. So yes or no, right? So our question is, how do we take these 3 items and code them for the SPSS database, and then list them in the data dictionary so we remember the codes, and also if someone else is doing data entry, they need to know the codes too, so they could enter the survey items, the data from the survey items, into the SPSS database. So the first thing we do is we give names to the survey items, right? So they should be short, about 8 digits or less would be great, and identifiable. So you can see for the first one, so ID is usually ID within the database, so that's fine. So you can see for highest education level, we have given the name EDUC, E-D-U-C. Right? So in the SPSS database, the name of highest education level will be EDUC. Right? And then income, we just call it income. And have you ever had a drink of alcohol, that is? Drink out. Right? So you can see we just put a text box to the left of the item. Right? Within the text box, we entered the name, and we made it bold and in red so it stands out. So there are several ways of making a data dictionary, but such as making grids and things like that. But I find if you keep it looking like the study survey, it's easier to reference the survey to find the items you need. If you make it not look like the study survey, like in columns and grids, it becomes a little more difficult. But that might be personal choice. just in one big column, you could do that too. All right, next you'll see that next to the responses, numbers have appeared. Right? So you can see, for example, in Educ, the first response, high school GED, now has number 1 in it. And so in quantitative analysis, like in our SPSS database, things have to be numbers, not letters, right? So we've assigned the response 1, high school GED, to response B, right, college 4-year degree. We assigned it 2, and then a 3 to graduate school. So income, right, is just the raw number given by the study participant. So that's entered there. And then drink alcohol, we have a 1 for yes and a 0 for no. And we always keep 0 no, or no 0, either one. So you can see that the numbers are again red and bolded, so they stand out from the original study survey. Now, a special note, when you're coding multiple items that comprise one measure, like the happiness scale, so we have a happiness scale measure, which we mention as a composite score of 5 items. Right? So when you have 5 items that make one survey, you could imagine you might like to keep them, have some common theme to recognize that the 5 items go together. And so for our happiness measure, it says, do you feel happy? Do you feel sad? Do you feel strong? Right? So in our database, right, so do you feel in the last 7 days, have you felt happy? Right? So that's feel happy. Then in the last 7 days, have you felt sad? Right? That's feel sad. So you can see for all 5, there's the common term feel, so we know that they all go together. Right? Or you can even put the numbers in there too. Right? So it's Q1 feel happy, Q2 feel sad. Right? So you could tell they're set. And the special case of all that apply. So if you have an item, so it might be one item, but within it, it's has this ever happened to you, and it's like A, B, or C within it, each item becomes its own separate variable. And I'll illustrate that in a minute. And again, we're going to go over why it's important to keep yes equals 1 and no equals 0 in this instance. Right? For example, if we were talking about exposure to community violence, right? We want to say, has this ever happened to you? Has that ever happened to you, right? So check all that apply. Have you ever been A, mugged, right? B, robbed, or C, chased, right? So it wouldn't be one item, right, where it's like, has this ever happened? 1 mugged, 2 robbed, 3 chased, right? Because if there could be different combinations. You could have been mugged and not robbed, but chased also, but chased and robbed, right? So to address that, we would just make each yes or no. Has this happened? Yes or no, right? So have you been mugged? Yes or no. Have you been robbed? Yes or no. Chased? Yes or no. Now the reason we like to keep it no 0 is that if all, so it's actually the final number produced that makes it so important that we keep no 0. For example, let's say, as in the first line here, you experience everything, all X. So you experienced all 3 exposures to community violence, right? If yes equals 1, right? So mugged, robbed, right? So it's 1, 1, 1. Yes, yes, yes. 1, 1, 1. 1 plus 1 plus 1 equals 3. So all exposures equal 3. So that's fine. Now, on the second line here, where it says no X, so no exposures, where no equals 2, right, it's no, no, no. So that becomes 2 plus 2 plus 2, which equals 6. So if yes is 1 and no is 2, full exposure has a score of 3, and no exposure has a score of 6. So a no exposure has twice the score of a full exposure, which is kind of awkward. So you can see on the bottom line, where no exposure, where no equals 0, if you've had no exposure, right, no, 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 becomes 0 plus 0 plus 0, which is a score of 0. So full exposure would be 3, and no exposure would be 0, which makes a lot more sense. Typically, there are missing data within a study. That being the case, you have to figure out what you'll put in the cell in lieu of the missing data. So one good idea is to put something in the cell which is not a probable response for the item itself. So what do I mean by that? So age, right? So for example, if we have age and then we have a missing data point, we don't want to call the missing data point 7 or 77 because that might look like the person's age is 7 or 77. So if we have the variable age and we have a missing data point, we might call it 777 because that's not a likely response to the variable age. So typically, you do well to make missing, right? So when a study participant just didn't provide a data point, right, just call that missing, that's 777. And if it's refused, as in the study participant said, I don't want to tell you, that could be coded as 888. And when it's not applicable, right, we can call that 999. So that's in instances such as, you know, I say, during your last skiing trip, did you enjoy A, B, or C? And the person says, I've never been skiing. That could be not applicable. That could be 999. Right now, part 2, entering the data. Right? So we're going to create the software database to enter the data into, and then we're going to actually enter the data. So you'll see when we go into SPSS variable view that there are going to be 11 areas to complete for each variable. There are 5 areas within the 11 that we call primary, right? As in, if they're not done correctly, you can't actually do the study. So the first is name, where we put in the name we assign the variable. The second is variable type, so we'll go over that. The third is the label, which is the phrase for the variable. 4, the assigned values, we gave the variables. And then 5 are missing codes. So these are the 5 primary areas to address within each variable. Right? To expound a little, right? So we have our name, right? So then type really fast. So usually there's 3. The default in SPSS and the most commonly used is numeric because it's a quantitative study, so you need numbers. Then 2 is string. That's when it's text data, most often speaking responses, right? You ask a question and then a person responds and you just type in what they said. And the third is date. And so something occurred on a date, you could set the format to date and enter the date. There's a label. Right, so you enter the phrase from the item, right? So actually, it's often useful to use the exact item phrase from the study survey. So if it says, how happy were you, you just put right in there in the label in the database, how happy were you, right? You can even cut and paste the item out of Word right into the SPSS database, right? Then 4, we have our values, the assigned values, and 5, we're going to enter, there's the column for missing, and we're going to enter our missing codes in the missing column. Well, not the missing column, the column for missing. It's there. Okay. So we have our study survey, and this one is completed. Okay? You know that because that's completed, first of all, but also you can see the little circles. Somebody circled for highest education. They circled C for graduate school and put in their personal income of $100,000. And then, have you ever had a drink? They said no. Right? So you see the little circles. So now our task becomes, how to enter this into the database, right? So first, let's get back to where we were in the data. And so if we open the database in SPSS, we just go to right here. So if you go to File and then New and then Data, you get a blank sheet just like this. So this is the aforementioned SPSS database, right? So down here on the left, we have Data View, where you enter the data. We're not there yet. And then Variable View, where you create the variables, which is where we are, right? So we have the columns mentioned. So the 5 primary, there's name, there's type, right? There's label, and values, and missing, right? So those are our 5 primary columns, right? So the first thing we do is we go under name, right? So you remember the first variable on the study survey was the ID variable, and that's very, very common. Right, so we just enter ID. Okay, so there it is. You see it's activated. So we go over to label, and we might enter something like, ID, or study participant ID. Right, so this is kind of, we don't need values and missing because there shouldn't be any missing. Everyone should have an ID. So we're assigning it, so if it's missing, it's more our fault, so we can fix it, so we don't really need to fill in the missing column. And then you'll see the second one, if you recall, the highest education level completed, we called that EDUC. So it's EDUC, right? So we just enter in EDUC, right? So EDUC, and then we go over to label, and we just type in highest education level, completed, right? So there we go, that's there. And then values, if you recall, I'll just make this real short. So one, if you recall, was high school or GED. So we might call that HS, GED, and then you just click Add. And this is what you do for each of them, right? High school, and then second was college or 4-year degree, and then third was grad school. And add, right, so there we go, click. So we have name done, label done, values done, and so then we need missing. And so the discrete missing values. This tells the database, if you enter this, enter these numbers, then it's missing, right? So the item is missing. So 777, 888, and then 999. There you go. And this can be actually, you see copy, and then you can cut and paste it down for the other items as you can for the others. And then for type, right, that was our other important one, it's numeric. Right, so we're putting 1, 2, 3. So numeric works fine, but if you click on it, you have the option to change it to string. If it's text responses, and you specify the number of characters here. If it's a short one-word text response, right, 8 characters is fine. But if it's long, you might want to make it 200 characters, right? Then we could change it to date if we wanted. There's a date format, but we're going to want to keep that at number, numeric. And we say OK, right? So we just do the same thing for all the other variables, and then you have variable view, right, where the data is entered. For example, ID 1, right? And then if you remember, they had a grad school level education, so they would get 3, right? And then we would just continue across the board for each variable. And then if you click this is a useful button. If you click that, the 3 becomes the actual text response. So you can see Educ is 3, but if you click that, you see the text response, Educ is grad school. So that's basically the data creation and the beginning of the data entry. And once it's all completed, right, that's what it looks like. So there's the data view with everything completed, and there's the variable view with all the items created, right? Just what we mentioned before, age and Educ, and a feel good, feel happy, feel strong, right? Number of drinks, drink alcohol, right? So it's all there. So next, if we come back, right, so then after the database is created and we've entered the data, right, the next thing is to clean the data, right? So the first part of cleaning the data is often referencing the hard copies against what's in the database, right? So for example, if I have the hard copy, right, that we mentioned, and it says, for study participant 1, on the actual physical paper, income equals 100,000. Then we look within our SPSS database, and we look and we see, for study participant number 1, is there $100,000 in the income cell, right? And we just do that across the board and just look at every item and see if the correct data are in the database for that study participant. And this could be kind of time-consuming, so if you don't have the resources or time to do each survey like that, as you can see at the bottom, if you can't do all of them, consider 10%. So if you have 100 surveys, maybe randomly select 10 of them, and then check the hard copy of the survey against what's in the database. And if it's accurate, it's likely that the other surveys are pretty accurate. And if there are mistakes, you might want to check the other surveys, because there's probably more mistakes if there's some mistakes on that sample. Examining the variables, right? A big part of this is looking for evidence of invalid responses. So generally, you could start this off by running a frequency analysis and see if there's any values outside the possible scoring scheme. Well, what does that mean? So if we go back to the SPSS database, here we see our variables, right? Now we know, for example, feel happy, right? For example, that should have a response of 1 to 5. Okay, so all the responses should be 1, 2, 3, 4, or 5. An invalid response would be anything below 1, such as 0, and anything above 5. So for each variable, we would run a frequency analysis, which is we go to Analyze, Descriptive Statistics, and Frequencies. Then we could go down to Feel Happy. And again, we do, this is just an example. We do it with all of them. But right now, just the one. Put Feel Happy in the right-hand column. And remember, you could click Haste or Paste, right? OK or Paste, right? So here we'll click OK, because we're not going to save this in text. And we could see that for Feel Happy, right, so there's 1 through 5 is strongly disagree to strongly agree. So that's 1, 2, 3, 4, 5. But you can only see the text. Right, so strongly disagree, right? That's all fine. But then you see down here there's a 6. So someone has entered a 6 for the Feel Happy variable, which is outside the coding scheme. Right? So that's not acceptable. So we have to find where that 6 is. And also, we have to figure out what that 6 should be. So we have to find the study ID that has the 6. So we have to see who got the 6. Then we can go back to the hard copy of the study survey and see what they filled in for the Feel Happy variable. Many times it's a misentry, right? So the data enterer might have put a 6 when the response was a 5. You know, so they might have meant to press 5, but they, went a little to the right and pressed 6. So if that's the case, we could just replace the 6 with a 5. But first, we have to figure out, like I said, who got that item as a 6 and go back to the hard copy and find out what they should have. So if we go back to the SPSS database, right, and we have our Feel Happy here, if you click on the number, it goes back to the other side. There's Feel Happy, right? Well, the 6 is up top. But if the 6 was not up top, and you wanted it to go to the top, so you could see the study ID. Let's see, where's the study ID? And so there's the ID. So we see study ID 1 has a response of 6. Now, if 6 was somewhere down here and you couldn't find it, you can right-click on the variable and click Sort Descending, right? And the highest number, see, 4, 5, 6. So the highest number comes to the top. If 6 was actually a 0, right, like this, so let's click Sort Descending. So if we had a 0 and we couldn't find it, we could click Sort Ascending, and there's the 0. Right? So that's Sort Ascending and Descending is also always a useful function. So it's good to keep in mind. Okay, so anyway, we see here that ID number 1 is the one that has a 6, right? So if we reference the hard copy, let's say we did that per se, and we saw that ID number 1, so the study survey with the ID 1 for Feel Happy has a 5. We could just go in and put a 5, and then it's fixed. And we can go on with our analysis. So that's looking for our invalid responses. Okay, so not too bad. So 2, looking at our invalid responses, right, examining the variables. Now 3, violations in logic. this could be many things. And for example, it could be a conflict within skip patterns, or it could just be something that doesn't make sense. So if I said to you, like with the community violence, how often have you been chased? And somebody said in the last month, like 88 times, first, that's a high number. But second of all, you know, you could say to yourself, well, would somebody really remember the count of 88 times in the last month, especially if they weren't counting on purpose and they were just asked in the survey? And so maybe, maybe not. It's things you need to think about, right? Violations in logic. Is it logical? Is it not logical? So for our conflicts within skip patterns, right, this is a little clearer. If somebody says, right, so if the first part of the item says, have you ever had a drink? And the person says no, that's fine. But if the second part of the item is, how many drinks did you have last week? And the person says 3, that conflicts, right? So you can't never have had a drink and had 3 drinks last week. Right? So a lot of the time this becomes missing data. And to check for such violations in logic, you would again go back to the SPSS database. And there's a few ways of doing it. One way of doing it is selecting the select function. You'll see. So suppose we go to select cases. Right? So this is data. And then down here, select cases. So we go to select cases, and up top here we select if conditions satisfied, and then if. Then we can scroll down here and find our ever had a drink of alcohol. Put in there equals. How about equals 0, which is no. So the people that say they never had a drink of alcohol, continue, and then OK. Like you can paste that. You see, pasting is done a lot more with the inferential analysis than the actual checks of the data and cleaning. So you can see on the left here, in the blue column, there's these little hash marks. These strike out everybody who reports the yes, right? So it's only including the no. So ever had a drink of alcohol? The yes, yes, yes are all excluded. It's only the zeros, right? So 0, no, and it should have 999, not applicable. So we go to Analyze, Descriptive, Statistics and Frequencies, and we put back the Feel Happy, and we go down to Ever Had a Drink. So again, because we've selected no, right, this should all be 999s. So anyone that's not had a drink should not have any data. Right? So ever had a drink of alcohol and the number of drinks last week. All right, here we go. So you can see there's 46 people that never had a drink of alcohol, right? So if these 46 people never had a drink of alcohol, they shouldn't have had any drinks last week. So if we go back here and we put this in here, and we go over here, number of drinks. Aha, you see? So 45 have not applicable, but one person says 3. So one of those 46 said they had 3 drinks last week. Then we have to find who that person is. So again, the sort variable is often useful. So if we sort that ascending, say we have our no, 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 and then the number of drink last week. So it's often real good to actually go in the data and look for yourself, rather than just running frequencies. So you could see how many people. Right, so there's no, 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 no. You keep up. There you go. So if you keep going down the nose, eventually you'll see no, but over here is not 999. It's 3. Right? So we see they said they have not had a drink, but they had 3 drinks last week. Right? And then if you scroll over, you can see it's study ID 94. So you could go to the hard copy of ID 94 and check and see if that's an accurate entry. If they really said no and then 3, right, you could check it out. And if they did, most often that's considered missing data because you don't know the truth. Is this the truth, never had a drink? Or is this the truth, they had 3 drinks and this should be 1? You don't know. So that would be, that could be actually taken out and noted that it was removed. So what are you going to do? It happens. Okay. And then recoding the variables. Recoding, so there's a few things in SPSS that are very useful that you do a lot. And recoding the variables is one of those things. Okay, so we'll go over real fast how to do it. It's in the text. So, for example, which variables need recoding? And you'll see in our 5-item happiness instrument, SAD needs to be recoded. What do I mean? Right, so here's what I mean. So here we have our 5-item happiness scale. Right? So you'll see for happy, right, 1 is strongly disagree, and then 5 is, strongly agree, right? So we have these items, or you see in SAD though, you see in SAD, right, that a score of 5, which is the highest, actually indicates the least amount of happiness. So we have to change that so that a score of 1 actually indicates the highest level of happiness. So we'll do that right now. So if we go back to SPSS database, right, and we want to recode feel sad, you go to transform, recode into different variables, and then we find in the left here, feel sad. We put it over, and then it's in the middle column, feel sad, and we give it a new name, such as feel sad REV, feel sad reversed. Okay, so we know this is going to be the new variable name, feel sad reversed. You can put a label, and now I like to put it in after it's created. So, but this would be where you would say recoded item feel sad reversed. Right, so feel sad reverse scored. All right, and then you go into here where it says old and new values. Click that. Right, so basically everything just becomes its opposite. So we have 1 becomes a 5. Right, and then 2 becomes a 4. 3 remains a 3. 4 becomes a 2. And 5 becomes a 1. So basically it's just putting everything in the opposite order. Because if someone says feel sad 1, that indicates the most level of happiness, the highest level of happiness. So we want to make that a 5. Because for the other items, 5 equals the highest level of happiness. And continue. And this we do want to paste. So we click paste, right? And then you have it right there. So instead of pressing OK, as we said, as we did before, but caution not, so you click that. You can save the syntax file, and then you click the green button. And so it's recoded, and then it says right here that the recode was successful. Then it's always good to do a frequencies. Right, so if we have feel sad, and feel sad reversed, then click OK. You could see originally it was discrete 1032.4. Now it's reversed 1032.4 going the other way. Oh, and don't forget, a little caution for you, take off your filter, right? There you go. So you might say, hey, there's only 46 people. There's supposed to be 100, right? So there you go, a little cautionary tale for you. And then click it, and there you go. So there's a full 100. So it was 8, 24, 49, 11. So you can see it's all reversed now. 8, 24, 49, 11, 6. All right. So that is our data entry process. So a little quick note. Lao Tzu once said that a journey of 1,000 miles begins with a single step. So just remember, a study of 1,000 study participants begins with a single keystroke. So analysis does not begin with statistical testing. It begins when the first data point was entered. That's the beginning of the quantitative analysis, right? Because if that's not done right, nothing afterwards is done right. Right? So we looked at our mistakes, our cleaning. So if it's not done right, you have to redo it, right? Because the findings will be wrong if it's not done right. So we'll take it seriously and do it right. Next week, we will be looking at step 3, checks of data integrity. And thank you again for watching this week's webinar presentation. Have a good week.